when everything's just involving x. And I hated having all these y's through there, especially when it was tan y or y squared. So I thought I'd change it in terms of x's. I did need to introduce trigonometry. So some might say, what on earth are you doing, Mr. McHarris? You're trying to make this easier, but you're trying to get me to do trigonometric differentiation? But I'm saying it's worth the cost. Emma, have you got any thoughts about what this trick does? Lucy?
So when you're differentiating y, you're just putting it as dy over dx rather than finding the value.
So do you have doubts about this trick?
I don't see why it's necessarily better than that one.
I don't understand how
That's the central question. The central question is, if I'd asked you to differentiate that with respect to x, would you have been able to see that it was that?
Yeah.
Well, this is my point. Okay, well you're better than me. Okay? Depending on how well you were trained with the chain rule, you might be able to see that. Okay? But that differentiating to become that? Yeah? Who's with Emma on this?
I think if you read the textbook and they've got through the examples the way they do it, I think I don't see the difference in the methods. Like, if they're easy or what.
Okay, well you don't have to use it. I wrote this when I was your age because I was terrified when I saw in the book this becoming this becoming this. This becoming this. I mean, okay, maybe I'm with you on the other ones, but are you telling me that you can differentiate that and get that? Well, you guys are great. Is anyone with me on this?
I don't understand how it works. Like, why?
I'll explain that in a bit.
X?
I'll explain that in a bit.
Okay.
But so none of you are with me on this. None of you think that there's high chance of error.
Slightly
less risky.
Yeah, but practicing the other one, I do feel.
So you don't want to use the other one.
I'll give this one a go.
No, but I want to hear your reasons. I want to hear your reasons because there's a risk with this, which I'm going to show you in a second. It explains why I chose y equals tan x.
Okay.
Shall I explain the risk? This would have been an absolute disaster. If I'd gone y equals sin x, it would have been an absolute disaster. Or this is even worse. What if I'd done that? That would have been even worse. Because then you would have had dy dx equals cos x, and you would have had dy dx equals e to the power of x. Why would that have been an absolute disaster? They're the same thing. Why does that kill you? Here you mean tell the difference between, yeah? When this step here, you go back and you replace all the trigonometry with what it was, you won't be able to do that here. Because you won't know which e to the power of x's should be replaced with y, and which one should be replaced with dy dx. So that is an absolute disaster. This one is also highly likely to be it's highly likely to lead to error because sin x's and cos x's, they become each other in the flick of a switch or in a heartbeat, don't they? Because of things like this.
But isn't that the same between tan x and
Not quite so bad though.
Is this a Polish refraction?
So what I'm admitting that this is a highly risky strategy. You should only use it when you're absolutely confident that you'll be able to go back at the end and clearly tell which are the things that came from derivatives or the original function and which aren't. If you have any doubt about that, so for example, never use this technique on a question that has tan x in it already, or if you do use it, pick something else to pretend that y is equal to. Does that make sense? So I guess what I'm really recommending is that you try your best to do it by inspection like you were saying that you could. But if you're in any doubt, use this, or at least convince yourself in your head that the process that you're applying, the x's and the y's, is the same as the process you would have applied if the y was equal to tan. And then just do a little mental check. You get what I'm saying? So basically the principle of this section is you basically just differentiate 5 things with pluses and minuses and equal sign in between. Yeah? And then if it's just an algebra question, you have to get y dx by itself. If it's not, substitute in and then get dy dx by itself. Do you want to see another example? Or are you good to go? Yeah? Okay, there we go.